welcome to my video. In this video, I will be talking about stars. A star is a giant ball of plasma that emits light from its surface. We have a white star at the center of the solar system, known as the Sun. Stars comprise a major part of the matter that makes up the universe, as they move up to form galaxies. In this video, I will be talking about the types, structure, process, life cycle, and distribution of stars. Stars exist in various colors, sizes, and compositions. Some stars are significantly more powerful than the Sun, and some stars are weaker than the Sun. The most luminous stars are classified as O-type and are blue in color. The dimmest stars are classified as M-type and are red in color. While the Sun is certainly a large object, stars are capable of reaching far larger sizes than it. If we look inside of the Sun, we will learn a lot about how it and other stars function. At the center of every star is the core, and all stars produce energy by nuclear fusion in their cores. Because of the immense mass of stars, atoms are forced to fuse together to form heavier elements. This process of fusion produces huge amounts of energy in the form of heat and light. Because the core is the area that generates energy, it is the absolute hardest part of a star. To better understand the heat distribution within stars, consider the fact that the temperature of the core of the Sun is about 15 million degrees Kelvin, but the temperature of the surface is only about 6,000 degrees Kelvin. Photons produced in the core are believed to take tens of thousands of years to travel outward and cross the radiative zone. Above the radiative zone of the Sun is the convective zone, where energy is transferred through the process of convection. Both the radiative and convective zones of stars make up the vast majority of their interior structures. Remember, though, that the order and sizes of the radiative and convective zones vary from star to star. The uppermost layers of a star are the photosphere, chromosphere, and lastly, the corona. The photosphere is the actual surface of a star that you can clearly see. This is the point where light finally escapes the star and travels out through space. The chromosphere is the lower atmosphere, and the upper atmosphere is the corona. Interestingly, the temperature of the Sun's corona is over 100 times hotter than the surface, or photosphere below. Stars are colossal nuclear reactors that have very long lifespans. These heavenly powerhouses did not simply pop into existence. They had to be born first. Stars are known to form in molecular clouds called nebulae, which consist of gas, dust, and other materials. As the fine materials of the nebulae condense under gravity, they become more attractive, leading to a chain reaction of growth. Eventually, a protostar is formed by the huge quantities of condensed gas, and thousands of years of further growth sparks the beginning of nuclear fusion, transitioning the protostar into a main sequence or mature star, like the Sun. The Sun is estimated to be capable of burning brightly for about 10 billion years. but is already about 4.6 billion years old. So this means it should last for approximately 5 billion more years before the end of its life as a main sequence star. The lifespans of other stars vary, depending on many factors, but they generally can live for billions of years as a main sequence star. When a star becomes too old, it must die. However, in many cases, death is not the end of the star. The final stages of a star could lead to a whimper or a bang, but usually there is a remnant that lingers for a far longer time than the star spent in the main sequence stage. Smaller, weaker stars may simply wither away and become dim, dwarf stars. And larger, more powerful stars may end their life with a great explosion called a supernova. Lesser supernovae generally leave behind a neutron star, which is extremely dense, yet relatively small. Greater supernovae may leave behind a black hole, because the immense mass of the dead star was enough to fill a region of space so tightly packed with matter that even light cannot escape. Stars are spread across the observable universe. Galaxies are collections of stars, containing millions to even trillions of them. Our Milky Way galaxy contains somewhere between 100 billion and 400 billion stars. Now imagine how many stars there are within the billions of galaxies that make up the observable universe. The closest star to the Sun is Proxima Centauri, being about 4.2 light years away. Within the galaxy, stars are usually several light years away from each other. However, some stars orbit each other in what is called a multiple star system. Binary stars are two gravitationally bound stars. Trinary stars are three, and so on. Star systems that have a huge amount of bound stars are called globular clusters. Now you know more about the stars that surround you in every direction. It is my hope that you will expand your knowledge of them beyond the teachings of this video. May Starlight guide you on your